Hi everyone and welcome back. So we are going to be talking about trigonometric identities today. So I just wanted to start us off with kind of a quick do now question. It's been a while since you've seen a question like this. So I wanted to just remind us how to solve something like this. So to evaluate this, do you guys remember when we talked about cofunctions? I know this was from a while ago. So cofunctions, that's when we talked about the sum of the angles added up to 90 degrees. So if I had sine of 90 minus x, its cofunction was the cosine of x. If I had the secant of 90 minus x, it was equal to cosecant of x because that was its cofunction. Okay, so I'm just trying to see if we remember some information like this. So just remembering the cofunctions. All right, and I can write them on the side for you if we forgot. So in this situation, sine of pi over 2, that's really just 90 degrees. So the sine of 90 minus x is the same thing as the cosine of x, right? This is the same thing as cosine of x. And here, I have the cosine of 90 minus x, which is the same thing as sine of x. So if I have cosine over sine, well, cosine over sine, that's the same thing as cotangent, right? Because if you remember, tangent is equal to sine over cosine. Okay, so this would end up being cotangent. So let me write out the cofunctions, that way you guys have them. Okay, so these are all of your cofunctions. Again, if you want to write this down in case you forgot, just remembering what pairs with what, okay? So if you remember what I just said here, we're going to use that information for these few exercises. Now, the whole point of today's lesson is going to be talking about solving and proving trigonometric identities, but we do need to know some key pieces in order for us to do that. So we're just kind of building our skills here. So just a quick reminder that I do include, when we are working with identities, we're going to typically try to change our trigonometric functions in terms of sine and cosine. That's not always the case, but 95% of the time it's going to work out better that way with sines and cosines. So I just don't want you to forget about our reciprocal trig functions. All right, and I'll write down the rest of them here. I want to see though if you can come up with some of them on your own. So maybe pause the video here and see if you can list the rest of the trigonometric reciprocal trig functions. Okay, so there you have it. So we know cosecant is equal to 1 over sine. Sine is equal to 1 over cosecant. So we have those already given. We have cosine is equal to 1 over secant. And then secant is equal to 1 over cosine. Cotangent is 1 over tangent. Tangent is equal to 1 over cotangent. And then it's important you actually know that cotangent can be written in terms of sine and cosine as well as tangent. So make sure you have these written down somewhere. You're going to need to be referring to these quite a bit. So that, as well as the cofunctions we wrote up here, you never know when we're going to need them. Okay, so let's take a look at exercise 2. We have if tangent of 4x plus 40 is equal to cotangent of 2x minus 10, find x. So again, you have to recognize that tangent and cotangent are cofunctions. So that means what's inside of their parentheses are going to sum to 90 degrees, as we said earlier. Okay, so that would be referring to, we have our tangent and cotangent. So we're looking here that we're going to sum to 90 degrees. All right, so I have 4x plus 40 plus 2x minus 10, all is equal to 90 degrees. I'm just going to combine like terms here. I have 6x plus 30 is equal to 90. I'll end up getting 6x equals 60 and x equals 10. So x is going to equal 10. So answer choice A. Okay. Okay, so now for question 3, we need to evaluate the following trigonometric functions. So this requires us to remember points from that table. So I'm going to write my table of values on the side. If you want, you can do that as well. Okay, so this is our table of values on the side that if you want to refer to it, it's totally up to you. So if I take a look at the first one, it says evaluate tangent of 11 pi over 6. So you need to immediately recognize that its reference angle is pi over 6. Remember, we're just take a look at that denominator and we're looking at pi over that value. So pi over 6. So that means I am looking where is tangent? And pi over 6. My value is radical 3 over 2. So I know that tangent of pi over 6 is rad 3 over 2, but I need to evaluate which quadrant 11 pi over 6 is in. So if I check my all students take calculus, 11 pi over 6 is actually the fourth quadrant, where only cosine is positive, so that means tangent is going to be negative. So when I evaluate this, my tangent of 11 pi over 6, that's really negative rad 3 over 3. Okay, so we just wrote down that tangent of 11 pi over 6 is the negative rad 3 over 3. Now let's take a look at the cosine of 17 pi over 6. So now again, we need to recognize its reference angle is pi over 6, and I'm dealing with cosine. So we know it's going to be radical 3 over 2. But now it's a matter of figuring out which quadrant that this is in. So we have our all students take calculus. Okay, so we know it's going to be multiplied by radical 3 over 2, but it's a matter of whether it's negative or positive. So if I have 17 pi over 6, well, I don't know where that is. Well, let's see. If I subtract that by 360, a form of 360 would be 12 pi over 6. Because if you guys remember, we did this a while ago, 12 pi over 6 is the same thing as 2 pi, which is the same thing as 360 degrees. So really, I'm finding a coterminal angle right now. So if I take that 17 pi over 6 and subtract it out by 360 degrees, I will get 5 pi over 6, which is coterminal to this angle. So really, they're the equivalent. 17 pi over 6 is the exact same angle measure as 5 pi over 6. And the cosine of 5 pi over 6, well, 5 pi over 6 falls in the second quadrant, where sine is positive. So that means cosine is going to be negative. So when I multiply my solution out, I have negative times a negative is a positive. Rad 3 times rad 3 is just 3. And 3 times 2 is 6. So really this simplifies to a half. Okay? So that's how we take care of a question like this. Questions? Okay, awesome. Let's just keep going through. So now we're actually going to get to the nuts and bolts of today's lesson, which is on identities. So if you want to flip over to the next page here. So let's take a look at our identities. So I kind of already mentioned this or earlier, if you wrote it down on your paper. What is cotangent equal to in terms of sine and cosine? So we said tangent is equal to sine over cosine. So that means tangent, or cotangent, sorry, is equal to cosine over sine. Okay, so that's one of our identities, which we already wrote above. All right, awesome. Let's take a look at the next question. So we have sine squared theta plus cos squared theta is equal to 1. Okay, and our little hint of information here says use the unit circle to prove this identity. Okay, so I'm going to draw my unit circle here. Probably be helpful, sorry for my picture, probably be helpful to draw a triangle. And we want to prove the following statement. So we want to prove sine squared theta plus cos squared theta equals 1. So if I label my unit circle here, we'll call this x and we'll call this y. What's this value on the unit circle? Unit circle. This is the radius. Good. It is the radius. And what's the radius measure for a unit circle? Good. It's 1. This would be 1. Okay, well, I'm going to use the Pythagorean theorem here. Let's see. I have x squared plus y squared is going to equal 1 squared, right? Just using Pythagorean theorem. Okay. Well, if you guys remember, we talked about this earlier as well. Remember, x is representative of cosine, and y is representative of sine. Remember when we label our points, x is cosine and y is sine. Well, I'm just going to substitute this in then for x, and I'll substitute this in for y. I'll have cosine squared theta plus sine squared theta is equal to 1. Would you look at that? These two things are the exact same thing. If I use the commutative property, I can just rearrange the terms as sine squared theta plus cos squared theta to equal 1. It's the same thing. Okay? Awesome. This is called, just so you know, this is actually going to be really important. Make sure you add this to your list of identities. I actually gave you guys in your packet all of the identities that you're going to need to know and use to complete all the problems that we're going to be working on. So this is actually called a Pythagorean identity, which should make sense because we used the Pythagorean theorem here to find it. Awesome, awesome. You guys are doing great. Okay, let's go through and actually start to prove some identities now. Now, when you prove identities, this is actually really important. You do not work with both sides of the equations, and you never cross multiply. So I'm going to write that down for us. You do not work with both sides of the equation, and you never ever cross multiply. Okay, if you don't take it from me, at least take it from Taylor Swift. We never cross multiply when we're proving trigonometric identities. All right, so let's get started here. So what you're going to want to do is probably draw your line down the middle from the equal sign. So let's do that here. And we're going to try to get what's on the left-hand side identical to what's on the right-hand side. They need to be the same. So we should probably start by seeing how we can rearrange our terms here with tangent, sine, and cosine. So we can rewrite tangent as sine over cosine. I'll leave my sine theta as is. All right. And we have cosine theta. And that's equal to sine squared theta. So here I have cosine and cosine cancel, and I'm left with sine squared theta is equal to sine squared theta. So we did it. We proved this trigonometric identity. Done. That's it. Just got to see how you can make your substitutions. Like I said, you're most of the time probably want to get it in terms of sine and cosine. Okay? So let's take a look at question 4. All right, so again, never cross multiplying, and I'm just going to write this out again just to give myself some space. I have sine squared plus cosine squared is equal to secant theta. Draw that down the middle, all over cosine of theta. Okay, well, remember what we just proved earlier. What did we prove sine squared theta plus cos squared was equal to? It's equal to 1. Sine squared theta plus cos squared theta is equal to 1. So can't I just replace this with a 1? Yeah, why not? We just proved it. Sine squared theta plus cos squared theta is 1. So I'm looking at 1 over cosine theta, which is equal to secant of theta. And 1 over cosine of theta is just secant of theta. So we're done. That's it. We just proved that trigonometric identity. Whoop. We are doing fantastic. All right, let's look over on the next page here. Let's look at question 5. Now, I believe there was a typo on my part. This should say not cosecant, but this should say cosine of theta. Sorry about that. So I'll write that over here. This should have said sine theta plus cotangent of theta times cosine of theta equals cosecant of theta. So let's fit that on here. Sorry about that. Okay, so let's start to simplify what we got here. So we have sine theta plus our cotangent of theta. Well, I'm going to probably rewrite this in terms of sines and cosines. So I have sine theta plus cosine of theta over sine theta times cosine of theta is equal to cosecant of theta. Okay, well, I'll have sine theta plus cosine squared theta all over sine theta. If I multiply my sine theta by sine of theta over sine of theta, that way we have like denominators, so sine theta and then sine theta, because this is really just a form of 1. So now I'm looking at sine squared theta plus cosine squared theta, all over, same denominator, sine theta is equal to our cosecant of theta. Remember what we said earlier, using our Pythagorean identity, sine squared theta plus cos squared theta is just 1. So now I have 1 over the sine of theta, which if you remember, using our reciprocal trig functions, that's the same thing as cosecant of theta. So that works. There's our proof. Okay, so we just algebraically proved that identity. Fantastic. Okay, I'm going to clear up some space here just so we can start proving the next identity. So we're going to derive this identity. Ooh, how exciting. Okay, so let's start to derive that identity. So how do I turn sine into tangent? To turn sine into tangent, what can I divide everything by here? That way sine turns into tangent. Good, cosine squared theta. We're going to divide everything by cosine squared theta. Awesome. Okay. So sine squared theta over cosine squared theta is tangent squared theta. Cosine squared theta over cosine squared theta, that's the same thing over the same thing, so that's just 1. And 1 over cosine squared theta, well, that's secant squared theta. Okay, so we just derived that identity. Well, so far we now have, of our Pythagorean triples, we have sine squared theta plus cosine squared theta equals 1. We now have tangent squared theta plus 1 is equal to secant squared theta. So if we divided everything by cosine squared, what's another trig function I can divide everything by? So let's see if we can come up with another derivation. What's another thing I can divide this entire equation by instead of cosine? Yeah, let's divide everything out by sine. So if I divide everything out by sine squared theta, and divide out by sine squared theta. Okay. Well, sine over sine is just 1. What's cosine over sine? Good, that's cotangent, and then it's being squared, don't forget. So that's cotangent squared theta equals, well, what's 1 over sine squared theta? Good, cosecant squared theta. These are our 3 Pythagorean identities. You will need these. We will be referring to these. So these are our Pythagorean identities. Okay? Awesome. All right, let's just keep going through some more proofs, guys, and then I'll leave you to it to do some practice on your own. All right? So let's take a look at question 7 here. I apologize for the lack of space. You might want to write these on a separate sheet of paper if you choose. Okay? All right, so I have cosine theta plus sine theta. This whole thing is being squared all over 1 plus 2 sine theta cos theta. And we're trying to prove that equal to cosine theta, tangent theta, cosecant theta. Ooh, lots going on here. So I'm probably going to want to double distribute the numerator here. So let's double distribute the numerator. We will end up with cosine squared theta plus 2 cos theta sine theta plus sine squared theta all over 1 plus 2 sine theta cos theta. And on the right-hand side, I'm going to try to simplify things here. So remember, I want to get things in terms of sines and cosines. So let's change this. We have cosine stays. Tangent is the same thing as sine over cosine. And cosecant's the same thing as 1 over sine. So let's see what happens. Well, the sines cancel and the cosines cancel. So this is just equal to 1. So that left-hand side somehow is going to have to turn into a 1. Oh boy. Well, I want you guys to take a look at this. Do you notice how I have that Pythagorean identity again? What's sine squared plus cosine squared equal to again? That's just 1. So I'm going to write that down here. I really have 1 plus 2 cos theta sine theta all over 1 plus 2 sine theta cos theta. And we're proving that that equals 1. Well, guys, if you look, this cos theta sine theta, can't I just rewrite that as sine theta cos theta? Are they any different? No, they're just being multiplied. So let's write that then. We'll write that as sine theta cos theta. Then I want you to tell me what you notice. So let's write this as sine theta cos theta. I have the same thing on top being divided by the same thing on bottom. If I have the same thing over the same thing, what do you get? 1. This ends up equaling 1. And we did it. We proved it. All right, fantastic. Why don't we take a look at question number 9 here. All right, so again, I'm going to write this on the side here. We have cosine. I'm going to distribute. Cosine squared theta plus cosine plus sine squared theta. And we're trying to prove that that's equal to sine theta plus tan theta all over tan theta. Okay? All right, well, first thing that I already notice, what's cosine squared plus sine squared? 1. So I have 1 plus cos theta is equal to, all right, well, I'm going to break these up into my 2 fractions. I have sine theta over tan theta plus tan theta over tan theta. And sine over tangent, well, if we do our keep change flip, that's really sine over 1 times 1 over tangent. And 1 over tangent, right? 1 over tangent is really cotangent. And cotangent is the same thing as saying cosine over sine. So I'm going to write that. This is really the same thing as saying multiply by cosine over sine. Plus tan theta over tan theta is 1. I have the signs on top and bottom cancel. And we are left with, in fact, 1 plus cos theta does equal cos theta plus 1. They're the same thing. Woo! You guys are on a roll. All right, let's keep going through. So I'm going to do question 10, and I'm going to ask you guys to finish the rest of these questions on this page without me. And I'll post the solutions up here. But you'll do questions 1 through 4 on this page without me. Okay, so for question 10, again, we're going to simplify what we got here. So I'm going to rewrite. Let's see. And just because I have not a whole lot of space, let's write this out here like this. And I'm actually going to do my double distribution here. We know that that's equal to tan squared theta plus 2 tan theta cotangent theta plus cotangent squared theta. All right, so we want to prove that those 2 things are equal. Well, again, we always want to try to get things in terms of sines and cosines. I know that secant theta squared, remember our Pythagorean identities? Well, one of them, let's write them out. We had tan squared theta plus 1 equals secant squared theta. We had sine squared theta plus cosine squared theta equaled 1. And we also had cotangent squared theta plus 1 was equal to cosecant squared theta. So I already notice secant squared theta is equal to tan squared plus 1. So I'm going to write that right here. This is tan squared theta plus 1. And I also notice over here cosecant squared theta is equal to cotangent squared theta plus 1. So I'm going to write that here. Plus cotangent squared theta plus 1. So that takes care of the left-hand side for right now. I'm going to simplify on the right-hand side. I know that I can rearrange my terms, so let me do that first. So I have tangent squared theta plus cotangent squared theta plus 2 tan theta cotangent theta. Okay, and I'm going to rewrite my tan theta and cotangent. So I'm going to leave this as is. So this is really plus 2 times sine of theta over cosine of theta times cosine of theta over sine theta. Everything here cancels. So really, I'm left with tangent squared theta plus cotangent squared theta plus 2. So that's what I have left on the right-hand side. Let's see if we can get the left-hand side to simplify like that. All right, so I'll group my terms. Tangent squared theta plus cotangent squared theta plus cotangent squared theta. And 1 plus 1 is 2. And would you look at that? They do match. These two things are equal. Okay? Awesome. All right, so like I said, I would like you guys to pause the video here and get through 1 through 4 on your own. So pause the video here and I will post my solutions. Okay, so hopefully you ended up with the same solutions as me here. All right? So those are your answers for questions 1 through 4. If you'd like to stick around to see if your answers on the next page are the same as mine, you can do so as well. But this is about everything you guys need to get started on that homework. So if you want to stick around and just see if you get the same answers as me for 5 through 8, feel free. I'll post my solutions here. All right, and here are my solutions for those last 4 problems. All right, just pay attention to the Pythagorean triple identities for every single one of these questions. And I even tried to highlight over them where they took place. Tried to also indicate with the arrow as well. Okay? All right, guys, I hope you guys found this video helpful. You guys can get started on your Delta Math, and we'll talk soon. I even put at the bottom of your page here again, knowing all of these identities, you're going to need them for your Delta Math homework. All right? Have a good rest of your day.